Human beings need both. The ocean needs the mountains for supply of food. If you look here, that's one creek moving bed load down, and that bed load ends up eventually on our beaches. And without that connection, we're lost. So, taking a step backwards, one of the things that brought us to this point about doing some of the foreshore work was events like this one. And this is in 2001. And they lead to these kind of things: significant infrastructure damage. People, like you see that lady still walking on trying to walk on the seawall. It's like there's people that, as we got there and closed the seawall, one lady said, "The seawall saved my life, and I need to walk it every day." And this lady walks it every day, regardless of what debris is on there. So these kind of things, supported by Adrian's here over 40, 50 years of reports on the need to do something to our foreshore to protect it and make it more resilient over time, led us to looking at what we could do. So in 2005, we started developing some pilot projects, which we took forward to fisheries. And since that time, since 2006, when we got some money from council, we started doing work on the foreshore on these 8 pilot projects. And it's not uncommon today to see machines on the beach, and it's amazing the hundreds of calls we got when we first started these types of projects. What are you doing with a machine on the beach? How can you do this? How can you do that? And it's conditioning, because today people actually accept it. They see barges, they see rock being moved around. They ask questions, and people are very, very supportive now. So again, it's human conditioning almost. So now we're starting to think about that connection, going back to the connection between the ocean and the land. And as we look at what's happening on the land and opportunities that present themselves on the land, we start looking at what we're going to do in the ocean. You'll hear more about what we're proposing, but really we identify that we're going to be putting reefs in. Is this red button? We're going to be putting reefs in, underwater reefs now, to support some more work on the foreshore here and here. We also know that we've got potential development occurring around where we are today. We've got the Wetmore site, Kiwanis site. We've got some development opportunities here. Down in Ambleside, we have the whole 13th Street being redeveloped, the whole Ambleside revitalization. The Safeway site is coming up. And again, what is our potential in the ocean? We talked today a lot about the geo-exchange potential, but what else is there? So we're just asking that question. So some of these things, and I don't know how clear these pictures are, but this is Dunderave Pier, and if you see how high the waves were in 2001, they're actually clearing light standards. So we've got obligations under our climate change for the provincial by 2012. From a municipal perspective, we're supposed to be carbon neutral. 2020, we're trying to achieve a 33% reduction, and by 2050, we're trying to achieve an 80% reduction. All these things are integrated into the work we're doing on the foreshore. And one of those things is trying to reduce GHG emissions through alternate sources of energy, such as geo-exchange. New development, the numbers you hear thrown around now is that between 75 and 80% of buildings that exist today will be around in 2030 to 2050. So we know that we need to go into the retrofit business. So everything near the foreshore and the Ambleside area is a pretty good place to start because of the high density. I show a picture of the Pink Palace, which again, all running on water, so water boilers. Great opportunity to retrofit and lower GHGs and possibly make a business case for it. And just the whole idea of integrating the foreshore and foreshore opportunities, protecting opportunities along the foreshore. So one of the things that just going, what I've learned in the last few years, it's been amazing, is that we don't know what humans are doing along the foreshore. This is actually Ross Crescent, for those of you who know the area. Cypress Creek is an input, so we're getting bed load down this creek, we're getting bed load down this creek as well. And so you've got this natural beach occurring. But what's amazing is where this comes from. And where that comes from, I'll blow it up a little bit so you can see it. And where that comes from is actually the installation of hard walls right here. So if you step back and you look at the bigger picture, wave energy is coming in here. By installing 2 walls at the wrong angle, they're actually digging out the beach right here. It's a very, very good example of that. So if you could turn back the clock in West Van, if you could take away all the seawalls, it would be a great place to start, but you can't do that. So now we're looking at other solutions. So we've got that amazing opportunity to see these things with aerial photos today, so it really adds. When I say designed by nature, I love this picture because this is in LA. We're trying to take advantage in our designs to take advantage of what nature will provide us. In places like Los Angeles, where they've got some challenges with their water temperature, this is in one of the reservoirs. They're actually putting in millions of these black balls to absorb heat because the water temperature in the reservoir has gone up and it's created a chemical reaction creating bromate. So not a real popular drinking additive. The other part is, and again, is that it's not uncommon worldwide, the challenges that we're going through. When we play with nature, we lose. It's the ocean's a pretty serious worker, 24/7, 365 days a year, doesn't charge overtime. And this is a beach in Mexico. And when I got started on this work, we went to Mexico that winter, and as usual, everyone knows when you're starting stuff or you're getting interested in stuff, you walk around with your camera, you take pictures of everything, so I drove my wife nuts. But this is a beach, one part of the beach where they hadn't there was no incursions into the foreshore with the development. And what happened is, after the hurricanes, all the material where everyone had built out into the walls here, or into the ocean, had moved. So these beaches grew, while these guys ended up putting sandbags in, and so at a great expense. So the idea and what they're doing now is actually doing similar things to what we're doing, is they're building subtidal reefs to do some wave attenuation up here. So again, the principles that we've been working with on the foreshore are really trying to use nature as our biomimicry stuff. So we're trying to just pick up nature and build upon a better solution using nature. One last thing is that the one thing that I really learned in this is the integration of professional input is really important. And all the work and the successes that we're having, I hope, on our foreshore is really because we looked at this situation and we thought, will we approach this with an engineering approach with environmental considerations, or will we take this with environmental approach with engineering considerations? And what we did is we didn't do either. We just put them together, and we just let them work as they were working. And it's made such a difference, and it's amazing the meetings we have with the coastal engineers, the biologists, and how productive those are, because nobody's worried about, well, that's a hard engineering question, that's a hard biology question. Everyone's just meshed the two together, and we come up with far better solutions. And I'll let Scott take over. I think if there's questions, people can ask at the end.
I'm Scott Christie, as I mentioned earlier, and the reason I'm here, well, there's a question, why am I? Connections. It's a theme that you'll see throughout today. I'm here because I knew someone, and I had some expertise, and I was brought into the picture. Some might say I was here because I was in the wrong place at the wrong time. This project's been a great project. It was definitely the right place at the right time for me. So, the previous slide was nice warm beaches. Welcome back to West Vancouver, sub-zero rainforest. This is how it might have looked before West Van was created. Hundreds of streams, rivulets, wetlands draining into Burrard Inlet, delivering sediment, delivering nutrients for habitat. And along in West Vancouver. And through its natural development, it created covered areas, parking lots, buildings, prevented water from going to ground. In order to deal with all this water, we created sewers, culverts, and we channel all this water into a few creeks. And some of those creeks we've culverted, made them partly concrete, left some natural components. And so what happens when you do this is you end up with less sediment, because we have less exposed earth. We end up with higher velocities in the creeks, which suspends more sediment, the little bit that does get into the creeks. And when it goes down to the waterfront, it comes out of these culverts and gets ejected into deeper water where it's carried away by tides. So, see if it works. This is McDonald Creek during a rain event a couple of years ago. This is before the shoreline works were done. So the water comes down, hits the foreshore, and runs straight out. You can also see that it's a very coarse beach, which means there's not a lot of fines staying on the beach. They're getting transmitted out and carried away by the tide. So if some of you can get down to McDonald Creek and you have this in your mind and take a look at what's been done there, you'll very quickly see some of the technology that's been applied to prevent this process from taking place. The other thing that Westman did when it created itself is it decided it needed to protect itself. And so it created walls. It created walls of riprap and walls of concrete. These walls create hard surfaces, which Stephen alluded to a little bit earlier. These hard surfaces reflect waves, which causes turbulence and removes fines that are at the base of these walls. And then waves that come on an angle can run along it, pick up speed, and that increased speed suspends more material and carries it away as well. So the effect is that we end up with a beach that continues to drop. And as it drops, that means larger period waves, bigger waves can come up to the shore and strike the walls, which means greater turbulence, higher speeds, and you get this process continuing. And eventually, you get overtopping. The waves now, the big enough waves are getting in, and they're getting up on top of seawalls, flooding areas, and doing damage. So, I was brought in this project because of a habitat background. Worked with coastal engineering, and we created habitat features that provided wave protection. Or maybe it was wave protection that created habitat. It wasn't relevant as to who was in charge here. It was simply we had a job to do, which was to try and stop wave energy, and at the same time, create some habitat benefits. In the foreground, this is a habitat feature that's disrupting the wave energy, not allowing it to strike the seawall. In the background, we have the waves striking directly on the riprap slope and going up onto the seawall. So again, are we building salmon streams? Are we building sediment traps? Are we building wave protection? This is Lawson Creek. Again, there's large volumes of water that come out of these creeks, and it comes out at high velocity. So what was done in Lawson is, instead of this, used to be a sandy area that got blown out every time we had a big rain event, we created this armored corner and then forced the stream to grade itself onto the beach. So that reduced the velocity and allowed us to drop out some of the fines and also keep them on the beach for distribution later. So I'm going to go through a series of changes that have taken place since 2006. And in fact, this first set of slides here is a structure that we built just this past summer. This is looking towards the Hillside Pier from Lawson Pier. We created these two tombolas. They're offset. The coastal engineer felt that it was better to offset them. We were experimenting with different sediment pathways and how we were going to be successful. And of course, as soon as you put this larger, more stable rock on the beach, the kids show up. They're the first colonizers of anything that goes on. So a beach that was historically ankle-busting round rocks that under wave action ground up all or any marine life that decided to land there, that also made it very difficult for the public to access. Begins to change. And these tombolas have now created these little humps on the backside with these sweeping curves. And that's in the space of 6 months. These changes can occur rapidly or slowly. Depends on what Mother Nature delivers, depends on what Westman is doing on its shore. And also what's going on up the mountains. Remember this wall? This is a relatively small amount of material. The key here is that it actually has arrived and it's been deposited. This may stay like this for 2 years. It may change in 6 months. The point is, material that was being eroded is actually now coming into play. We're now starting to collect material. Again, this is looking west towards Lawson Pier, a beach that was relatively inhospitable to both the public as well as marine life. Now starts to change. Some of these changes are dramatic, some of them are very subtle. This is more of a change in sediment type than a change in elevation. So some of our pilot projects were geared for providing wave, some were for trying to accumulate material, some were trying to create better public access. This is Lawson Creek before the project. Lawson Creek after. We now have a very nice public amenity that I believe was donated and was built in the district. So we now get public interaction, we get public education. We end up with a huge habitat gain from a beach that was a large expanse of monolithic cobble with very little growing on it. We now create stable environments for biodiversity and increasing habitat. Looking off the end of Lawson Pier. So these rocks look like great habitat, and they are. But they're actually positioned in a certain way to try and recreate a sediment transport path that Lawson Pier blocked by sticking out to push water around the outside of the pier into deeper water. So these rocks are actually positioned in a way to try and maintain sediment pathways along the shore rather than letting it get pushed offshore. So when you look at these structures and you're walking along the beach, you say, wow, look at all the habitat. There are hidden values to these structures. Again, Lawson Creek. So, Stephen alluded to this a little bit earlier as well. Day or night, for a millennium, forever, if you build the structures on the beach, the mountains will supply the sediment to restore the beaches and protect the sea. It works all the time. How much material arrives will be a function of what, again, happens in terms of weather and happens up on the mountains. This one load of material here is 90 truckloads in one night, and it was free. And we, through the construction of these structures, managed to keep it on the upper beach rather than being injected out into the deeper water. So the pilots. Why were the pilots done? One, because they were cheap. They were easy to do, relatively speaking. The goal was to create biodiversity, create a better environment for the public. And if any of you, and I know Adrian has taken lots of pictures of the shoreline and some other members here, recurring theme is people are on the beach now. People are starting to participate in their environment. That connection between the upland and the marine environment is getting reestablished. And as more of us spend time down there through groups like Shoreline Preservation Society, Stream Keepers, Climate Action Group, these things like enhancements of streams and west salmon return and gillgrass beds and all that, that will all become, it'll just happen. So I don't have a before picture from this angle, but this is what Lawson looks like now. And the entire West Van shoreline can look similar to this. Different types of habitat, but there are real opportunities, and the pilots have proven that. So, in 2007, there was a document produced called the Shoreline Preservation Plan, and it was a 3-year plan, and it had budgets and projects and ideas to pursue. And the goal was that if the pilots proved out, these larger plans could be brought into focus, perhaps funding generated. Some of the projects, a 2-kilometer subtidal reef off of Dunderray here. create a kelp forest and stabilize the upper beach. Off Navy Jack Point, the subtitle map is to change bottom elevations to, again, provide support for the upper beach and force waves to crash further offshore and not against the wall. And a similar structure for Lawson Pier. So why are we here today? We're here to talk about the next step. The pilots will continue to get support and they'll continue to grow in small pieces. But we're talking about a much larger project. And a recurring theme between the coastal engineer and myself and staff was how do we make something that was working even better? And the concept of an ocean loop, which is not a new technology, could we add an ocean loop to a habitat feature? And what would it be? And so this is one idea. So you end up with an island structure, two island structures that create or reinstitute the sediment transport system, and start to build beaches, create public accesses along the entire waterfront, provide more park areas. This particular image shows the sailing club that was up here on Ambleside Beach is now out here. The sky is the limit. I've heard this project referred to as the Blue Sky Project. I think that's a positive comment. This is an opportunity for people's imaginations in this room through the course of the day to come into play. Perspective. This is the size of that project relative to West Vancouver. Perspective. When we captured one grain of sand that got ejected before, and we managed to keep it on the beach, we grow the beaches, and we protect the shoreline. One grain of sand. We do one pilot project that proves some technology and some environmental issues. It's one grain of sand. And in fact, this large-scale project that we're talking about today is the greatest